In today's note, we're going to be looking at periodic functions, and specifically we're going to be looking at sine waves. So what we're going to do first is investigate the values of sine theta. So again, remember theta represents any angle. So we're going to look at what's our sine ratio at a bunch of given angles. So what we're going to do is, using our calculator, we're going to calculate what sine of each angle is and record the value. Again, make sure that you have everything in degrees. So whether on your calculator you see DEG or D, that's what you want to see at the top. And when you enter these angles in, these are the values that you should be getting. So what we see here, we do see a repetition of numbers. So what we see, we should recognize that it is a periodic function. We are seeing some repetition. It's not exponential, it's not linear, it's not quadratic, because we have an up and a down. And if we were to continue on this, we would see that it does start to repeat. So at this 0 here, now it goes back up to positive 0.26 and so on. So taking these values next, what we want to do is we want to graph them. And when we graph our sine function, or our values for our sine function, this is what we should see. And this is going to be our standard sine wave that we refer to from now on throughout the course. But this is our main visualization of a periodic function. Again, we talked about if we continue on in either end, it will continue to repeat that pattern. So it will continue to go up as we move to the right, and then it will continue that up and down pattern. So a couple questions first based on this sine function. Is the above curve a function? And yes, it is a function. Why or why not? Well, because we have a graph, we could say that it passes the vertical line test. Again, if we're not sure what the vertical line test is, that is where we take a vertical line and drag it across our graph. In this case, we see that it only touches our function once. So there's only one y value for every x value. What is the domain of the sine function? Well, the domain of the sine function, because it continues on left and right forever, so this means that x can be equal any real number. What is the range for the sine function? Well, the range is, because we're dealing with a straight line, y equals any real number. But we have some restrictions because it can only go from -1 to +1. So that is what our range is for this function. Some key terminology that we've used with periodic functions before that we're going to continue. One is the equation of the axis, and this is the equation of the horizontal line that is halfway between the maximum and the minimum. So it's that line that cuts our periodic function in half. And if we can't visually see it, or we're having trouble determining it, we can use the formula y equals the max plus the min divided by 2. For the amplitude is the distance from the axis that we just talked about to either the maximum or the minimum value, and it's always positive. If we wanted to come up with an equation for that, we would say that the amplitude is equal to the max minus the min divided by 2. And to show that it has to be a positive number, we're going to put these two vertical lines. So basically that just means that regardless of what our answer is, whether it's positive or negative, we're always going to make sure that it's positive. That's all those lines indicate. And the period is length of one cycle. So again, one cycle or one repetition. So again, we talked about the sine function, we've graphed it, we saw some of the values from a table of values. This is going to be our key periodic function going forward. So there are some characteristics of it that we need to be aware of. The period or the length of one repetition is 360. Our maximum value is 1, our minimum value is 1. The equation of the axis is y equals 0. Again, remember that's that horizontal line that goes through. Actually, let's just color coordinate everything. So that's the horizontal line that goes through. We have our maximum at 1, our minimum at -1. And our period goes from here all the way to here. Our amplitude is again the distance from the axis to the maximum or from the axis to the minimum, and in either case it will be 1. And then finally our domain, we talked about our domain, x equals any real number, and our range, y equals any real number. However, it goes from -1 to +1. And there are 5 key points that we need to be aware of. So the 5 key points, the first one is 0, 0. Then we have 90 and 1. We have 180 and 0. We have 270 and -1. And we have 360 and 0. So again, those are the key points that we want to be aware of for our sine function. So even if we don't know any of the other values, if we know these 5 key points, we would still be able to roughly draw what our sine function looks like. So let's just do an example looking at our sine function. So for example, Sarah is sitting in an inner tube in a wave pool. The depth of the water below her in terms of time can be represented by the graph shown below. So we have our time, we have our height, and we're looking at her height above the pool bottom. So looking at this graph, the pool bottom would be at 0, and she's floating on this, say, inner tube up here. And she's again traveling on that path up and down. So I want to look at what is the period. So what is the period of this relation or this function? So I need to see where does it repeat. So an easy way to do that is to start at one point and just kind of trace along the line until we get back to that point where we started. So in this case, that's one cycle. And the length of the one cycle in this case would be 3. I need to know the maximum value. Well, the maximum value and the minimum value are down there. So the maximum in this case would be, because we're going up by 0.2, the maximum would be 2.4. The minimum would be 1.6. The equation of the axis is the midline, so I could do it one of two ways. I could do 2.4 plus 1.6 divided by 2, which equals 4 over 2, which equals 2, or by looking at it, I should be able to see roughly where that midline is. So the equation of my axis will be y equals 2. The amplitude, if we're not sure about the amplitude, by looking at it or by seeing what the height is from that midline and up, we could do it mathematically. So 2.4 minus 1.6 divided by 2. And when we do that, we get 0.4. And we can tell by looking at it that we go from 2 up to 2.4 or 2 down to 1.6. So our amplitude is 1.4. Our domain, again, depending on what we want to say, if we're saying that this graph only goes from, it's restricted to whatever we see here. So we could say the domain is x is going to equal any real number, and the restriction is that it goes from 0 all the way to 8, or we could say again just x is any real number depending on what the situation is, if it continues on forever or not. Our range, or the y value, y equals any real number because we're dealing with a continuous graph, and in the range it goes from 1.6 all the way up to 2.4. For looking at key points, again 5 key points, we're going to pick the first 5 that we kind of see, so we should be seeing we should be seeing 0 and 2, so our first point, because it's halfway through, or we'd say this one would be roughly 0.75 and 2.4. Then we have 1.5 and 0 and 2. We then have 2.25 and 1.6, and then we have 3 and 2. So where I got those numbers from, if I were to draw a table of values, x and y, I know I have 0 and 2 first, and then I got to make my way down to 3 and 2. If I know in the middle, 1.5, it does come back to 2, then halfway in between each of these is 2.25, and then this is 1.6, and 0.75, and 2.4. So basically I'm just taking the idea, because I know that the maximum is going to be like a quarter of the way through, and the minimum will be a third or 3/4 of the way through one cycle. That's what I'm basing those values off of. So if I know the start, the end, and the middle, I can figure out the other two. So again, that's a brief overview of looking at the sine wave. And again, the sine wave is going to be our main version of the periodic functions that we look at from now on.